In Java, the scope of a local variable is confined to the block in which it is declared. A block is any set of statements enclosed in braces, such as inside a method, where a method signature is followed by a pair of curly braces wherein the logic sits inside. Sometimes this pair of parentheses could be a part of a constructor, a loop, a conditional block, or any standalone block of code. Local variables are not accessible outside of the block where they're declared. When you have a local variable, let's say integer x, this x sits inside this block defined by a pair of curly braces. Therefore, you can infer the lifetime of this local variable is limited to the execution of the block. If what's inside this block is a collection of 5 statements, then that is the lifetime of that local variable in terms of its scope. Once the block of code is exited, the stack frame or activation frame for that method call or block is pop off of the call stack that we reviewed before, or activation frame, and the local variable is no longer accessible. This is to say that once a local variable is defined inside a particular scope or a block of code, you cannot declare the same variable twice. This is kind of obvious, which means even if you don't have this block of code, and simply just write integer I equals 5, for example, you declare and also define this variable I once, you cannot do it again in the following line and set it to something else. This will give you a compilation error. This means that this variable I is unique within that block of code. Let's look at some of the examples. Now, by definition, this static method, which is a function, has a scope on its own. This is the outer pair of braces, inside of which you have a for loop, which also has a pair of braces. This means that there is scope here. There's also a scope that encapsulates this entire method or function, wherein you have the scope of I and also scope of J. I is part of your for loop, whereas J is also part of your for loop. This means that both I and J are visible inside this loop scope. When your loop exits, let's say if you want to use J or I after this closing curly braces, your code would not know what I and J's are, because both I and J are local variables inside this for loop, not outside of it. So this is one example of the scope of local variables inside a loop. Let's look at another examples next. There are 2 functions. One of them is method 1, the other one is method 2. These are static. Let's look at the left one. We have 2 variables here, x and y. We also have this loop with integer I and another loop with integer I. Now, this integer I for this loop is local to this for loop. And this I has nothing to do with this I, which is local to another loop. However, both your x and y are what's called global vars or global variables. They are global to both for loops. Therefore, either for loops would have access to x and y. This is the reason why this entire block of code actually compiles. Let's look at this right-hand side. This particular method has 2 global variables, integer I and integer sum. Notice that inside this for loop, this I is declared once again. However, because this for loop sits inside your method 2, your for loop has visibility into its global variables. The problem is this for loop declares integer I again. Since I already exists, this throws a compilation error. To make this code compile, you can either get rid of this entire line altogether, so your code does not have integer I declared twice. The other way to make this compile, if you want to keep that global I variable, is to get rid of this declarations. You can simply just have I equals 1, and this I is the one that you declare in a global scope. Let's look at some more examples. This is a working code that illustrates a function with several global variables, x and y, and also local variables inside your for loop. There's no collisions here, meaning x could be referenced by either of these loops. X is global to them. The same argument applies to y, which is also global to both for loops. However, this I is particular to the first loop, so is this I, which is particular to this for loop. Both i's are local to their respective loops, so they don't run into any collisions, which means this entire code compiles. Let's look at this other one that does not compile. In this use case, we have two global variables, x and y. We also have an integer I. There's a problem here because in addition to that, inside this for loop, there's a local x. However, x already exists globally, and you can only have one global variable, a unique variable, declared. This x will run into collision with this x, throwing compilation errors, because this x is not the same as this x. This example illustrates one thing. Within their scope, this x, which bears the global scope, is visible to all subsequent lines of code within the same block, represented by this pair of curly braces. Recognizing the scope of these variables is very important in programming. It is also equally important to name your variables carefully instead of throwing x, y, and z. In some companies, they will have variable naming conventions such as G, X. G stands for global. There are many safeguards like these or best practices to prevent you from making the same mistake like what this code illustrates. This should complete our discussions on the scope of local and global variables and what constitutes a scope in Java.